there are two basic ideas that I'd like to deliver for you in this workshop, 6 hours workshop. The first idea is that it is quite doable to contribute to GHC. It is doable, and it's not something that is impossible. So I will try to convince you that it is a good idea when you learn Haskell to try to contribute something to compiler itself. So that's the first idea. It is very important for the community to have as much contributors as possible. So and in fact there are hundreds of contributors for GHC, and some of them are professionals with PhDs and something like that. But many of them are just students. For example, I have a student, and he was contributed to GHC at his third year at undergraduate studies at the university. So it is possible to do things like that. All right. So the first idea is contributing to GHC is doable, and the second idea, which is important in terms of Haskell development, is that type theory is not that theory, actually. It is something that works inside compiler, and we will see examples how it works. So how type theory is actually implemented, how it helps your Haskell programs to run. So it's no more a theory, it's just real practice inside a compiler. So that's the second idea, and I will talk much more about it. So we'll see how it works, how the most basic things from type theory comes into compiler implementation. So we should see that in this workshop. Although this is a workshop, in fact, I will be lecturing most of the time. I will give you an opportunity to do something by yourself at your laptops. If you have cloned this repo, then you can find everything that you need for those exercises there. And by the way, slides are also published in this repo. So if you clone it, you can find this set of slides there. So if you have problems with reading font size or something there, or you want to go back and see something different slide, you can download it, and then you can follow it at your own speed. All right. And please feel free to stop me at any moment to ask questions if you want to clarify something. I'm sorry if I'll have troubles understanding you. For me, it would be easier if you go, if you will talk slowly, and I think that I will have to ask you to say something again. Sorry about that. So I'm not that good in hearing English. So please keep that in mind. But please stop me any moment you like. So it's not a problem. I will continue right after I will answer to your questions. All right. So we'll start with short introduction into GHC and GHC development process. So we'll discuss very basic things about how to start actually with GHC, and I will give you links to where you can read about it. So GHC, it's really a project which is very good for contributing from the very beginning. So we're talking about Haskell compiler. Glasgow Haskell Compiler is one of the Haskell compilers. There are several others, although this one is, it's the only compiler which has industrial strength. So there are others, but they are mainly academic projects which try to learn something about programming languages and something like that. For example, there is a Haskell compiler from Intel, they are trying to make it very performant. For example, there are other compilers which are more about type theory research, but this is industrial compiler that can be used for whatever you like. So main website is right there, and there are several groups of people who run this compiler. The most important committee, GHC Steering Committee, is the most important one. It's about developing Haskell, about adding new features to GHC compiler. So there is a process of proposals. So if you want to deliver some feature to GHC, you just post this proposal on GitHub. Here it's like in the form of pull request. And then you can just propose something, or normally you can propose something with a original implementation, and you can provide some work before you do this proposal, and then this GHC steering committee analyze this, and then they vote, and then they try to do something with this proposal, and finally it may end up in the GHC head. There is also a Glasgow Haskell team. This is a team of contributors and committers. There are not too much people, about dozen or something like that, people who have right to commit to GHC code base. But it's possible to be a contributor, and there are several hundreds of contributors right now. So you have to provide a patch for GHC, and then one of committers, after reviewing it, will add it to the main code base. In fact, there are several other committees beyond this one. Beyond this GHC steering committee and this Glasgow Haskell team. There is also Haskell language committee, a committee for writing the next report, Haskell 2020. There is also Haskell libraries committee, about which goal is to develop new ideas for standard library, and there are several other committees, but these one are the most important for Glasgow Haskell Compiler itself. So it's not about Haskell language in general. It's about GHC code base. So this language is developed for about 30 years by now. So its development started in 1987. But GHC, the current code base, comes from, I think, 1992, 1993. So it's very old code base, 25 years at least. And that's actually means a lot. So if you have very old code base, you will never find some fresh Haskell things in this code base. So for example, there are no monad transformers there, there are no free monads, nothing like that. Even close, nothing like that. So it's quite simple Haskell code with very basic Haskell inside it. So nothing special in there. These are two key persons for Haskell community, Simon Peyton-Jones and Simon Marlowe. Simon Marlowe a little bit stepped up several years ago when he moved to Facebook, but before he was one of the most leading developers of Haskell. Simon Peyton-Jones is the most important person in the community, so everybody should know them. So if you want to do something with Haskell or GHC, you should know how they look like. So if you meet one of this person, then you have to come to him and then take a selfie with him, ask for the signatures on your, I don't know, on your body, on something.
Steal his phone.
So yeah, that's very important, and so please remember them. Okay, and this is one of the most interesting quotations from the paper. It's not actually a paper. The Glasgow Haskell Compiler is an article in the book Architecture of Open Source Applications. So there are many chapters in this book about different projects, like LLVM there, GNU compiler, and many others. And in this paper in 2012, Simon Marlowe and Simon Payton-Jones wrote this. And this is it's very important quote about development of Haskell compiler. So please see several things there. So they developed a compiler, but their original goal is doing research, actually. Research in type theory, research in compilation of functional programs, research in evaluation lambda expressions. So it's more about research. But for Haskell community, for the developers of GHC, it was always important to do research which is parallel with implementation. So for Haskell, it's almost impossible to do just research without actual programming something. So it's not plain theory. It's always something that you have in code base. So normally in Haskell, you have something like that. You have a paper at the conference, an international conference on functional programming, or in Haskell Symposium. You have some preliminary implementation before this paper, surely. And after symposia or after this conference, after this paper, you normally start doing something with GHC itself. And then it takes about 2 to 3 years before going into compiler. So first some preliminary work, then paper, then 2 or 3 years, and then you have this feature in the compiler. Sometimes it goes quicker. Sometimes it goes longer. For example, we'll see several examples here in this talk that it takes like 6 years. It's also possible between paper and actual implementation in the compiler. But it always goes like that. So some time slot between paper and actual implementation in the compiler. So again, in Haskell they are doing some research, and they feed these research results into GHC, and then it is possible for them to use these research results for new research. So you can use Glasgow Haskell Compiler as a laboratory for doing research in type theory, or in general in programming languages theory. So of course it's a compiler for writing blockchain applications in Haskell, but for Haskell developers the main thing is about doing research using this compiler. By the way, this article about Glasgow Haskell Compiler is very good. It was written in such a way like it was a result of 20 years development. So it's not very current right now, but it's still very useful for understanding how this development works. This is developers wiki. Here's this address website, main starting point for every person who wants to contribute to Haskell. So there are many informations in there. I will shortly say something about that. So it's not very modern Haskell development software development page. No web 3.0, 2.0, nothing like that. It's very old-fashioned, but it works. So just wiki, quite an old one. There is bug tracker there, which is not very modern, which is not very featureful, but still we can do that with. So it works. That's enough. What you can find there? So the most important section for us here is newcomers information. About 2 or 3 years ago, there was a big process of bringing Haskell to contributors, to bring more new contributors to Haskell. And at that period, this newcomers info were written, and there are many information about how to start with Haskell. So before that, it was very difficult to start, actually. No, it was very difficult to build a compiler. So right now it's a long process, but still it can be done in several steps. These steps, they can be like 1 hour, 2 hours, but you just write something, and then it takes an hour to compile it. You just wait and wait and wait. But so now it's simple. So you have simple steps. So there is information about building. Building Haskell compiler is rather difficult. There are many tools that are used there. The problem is that, well, you have this code base. It's 30 years old, and you have to build, at the same time, you have to build something for Windows, for Linux, for Mac, for other platforms too. So you have to configure this project to make it buildable for various platforms. And you know that every Linux is, sometimes it's just different platform. So many other different tools available there. You will need many compilers to compile Glasgow Haskell Compiler, for example. You will need some Glasgow Haskell Compiler to build Haskell Compiler. You will also need C compiler. You will need Python compiler. You will need Perl at your machine.
What?
Well, you will. You will need that. So yeah, it's a big project, you know. So there are many instructions on how to work on this compiler, how to do things when you want to develop something. There are many implementation details. This GHC commentary, by the way, if you download these slides, you will see it's links actually, not just these lines. So if you follow these links, you will find all this information. So GHC commentary is a document about different parts of a compiler. Unfortunately, this commentary is slightly outdated, and it is made more and more outdated every day. So developers try to change something with this, but it's rather difficult. So it's not always the most actual information in there. There are also many advice on debugging this code base, testing, profiling. It's not like a regular Haskell project, actually. For example, it is very difficult to load Haskell GHC models in GHCI, for example. So to run it in interpreter, it's not an easy task. It is possible, but you have to do many steps in order to achieve that. It is very difficult to profile it. So this advice is it's very helpful when you want to do things like that. And one of the most important for newcomers, after newcomers info, is these issues. So we have several kinds of issues there. We have, of course, bugs. Right now, we have, if I'm not mistaken, it's about 10,500 issues right now. Some of them are closed, but there are thousands of open issues. So we are waiting for you, for all of you. So we do need some people to close all those issues. Some of the issues are very old, like 5 years or 6 years, 7 years. We have such issues too. So there are not too much people there. There are also feature requests. When someone wants to get something in GHC. Right now, this feature request in this issue tracker is not something which is very popular. There are other steps to introduce, to propose new feature. But still, there are interesting features there. So you can use them for some inspiration. So if you want to do something with GHC, then you can just look at these feature requests and find something what you need. For example, I personally, 7 years ago, I was looking through these feature requests and find one which looked good to me. It was made by Philippe Badler like 10 years ago. So I just start working on on it, and it was my first contribution to Haskell. So so I tried this approach: find feature requests and then implement it. And there are also tasks there. Task is something which should be done, maybe now or later. So something that should be done someone. But it's not a bug, but just some small technical request on doing something. There are many other resources which you should know about when working on Haskell. On this wiki, developers wiki, there is GHC reading list. It's a huge reading list. There are several hundreds of papers in this reading list. Because as I already told you, when you develop something in Haskell, you wrote paper first, and then you implement it. So right now, Haskell code base, GHC code base, is based on several hundreds of papers. So if you want to work at it, then it's a good idea to read these papers. Maybe not all of them. Some of them are outdated, of course, because they are maybe 20 years ago or something. But some of them are pretty new. There is also other reading lists, Haskell implementation reading list from Stephen Deal. If you don't know who Stephen Deal is, then you should find him, because it's his website is great about Haskell. So just find him and read everything that he wrote about Haskell. It is very useful. And this reading list is also very useful for newcomers, especially because there Stephen Deal tried to compile the most important resources, and much less number of them than in main GHC reading list. The main, you can find source code for Haskell here in Git Haskell.org. Several years ago, maybe 5 or 10 years ago, I don't remember actually, this Haskell.org, there was not a Git Haskell.org, but there was Docs Haskell.org. Is anybody in this room knows what is Docs? Oh, great. So Docs is another control version system, very old one, which was implemented in Haskell, which implements actually algebra of patches. So it was algebra, actually. It was almost impossible to work with it. It was very slow, very unreliable, but it was an algebra. But then this code base switched to Git, and now it's a little bit more convenient. Unfortunately, so you have this main repository, and there is a mirror on GitHub. So GitHub is not used in Haskell GHC development process. It is, well, maybe it would be more convenient for newcomers to use GitHub with its pull requests and something like that. But unfortunately, right now, GitHub is just a mirror. So you can look at Haskell GHC code base there, but you cannot work with it. Technically, you can provide some pull requests which change something in documentation, or you can fix some typo in source code, something like that. But in general, you don't use GitHub for working with GHC. Instead, you should use Fabricator, this tool, Fabricator, from, I think it's from Facebook. So we use it for sending patches, for reviewing them. There are also tools for building, for validating code. This code base validating is, they have big test suite in this code base, and to validate it, it takes like 2 or 3 hours. There are many tests available, so we're using Hubmaster for that. But it's all integrated in Fabricator. So we have track with issues, so you can find information about issues there. And then if you implement something, then you go to Fabricator and then send patch in there, and then follow its approach about reviewing and everything else. Now let's talk a little bit about what is inside the compiler. So if you downloaded this code base, you will see many directories there. So let's talk about some of them. So here you can see in the red, they are the most important directories. The most important one where compiler itself is implemented, one about libraries, I will talk about them later, one about runtime system. Then in blue you can see here several directories about building Haskell, building this compiler, and I will talk about it later too. And now I will just say several words about other directories, because I find it very useful when you look at when you downloaded something. It is very useful to understand where to find what you need. So if you have several dozens of directories, then you can be completely lost and just don't want to look what is inside them. But in fact, you don't need most of these directories, actually. So you need only 2 or 3 of them normally. So we have bootstrapping there. Bootstrapping is a quite regular process for building compilers. Well, when you want to build a compiler, you need a compiler. This is basically bootstrapping. What is bootstrapping? So in order to build the newest version of compiler, you need normally previous version. Sometimes it is possible to build a compiler with several previous versions. Like if I'm not mistaken, now for building GHC 8.4, you will need 7.10 as the latest, not earlier. So you just build something in the very beginning using old compiler, and then you build new stages of a new compiler. I will talk about it later. So bootstrapping is about that. So how to start building a compiler. It is possible to build Haskell compiler on a platform where there is no Haskell compiler. So there is a process of using C compiler for building some original version of Haskell compiler, which is very small one, very limited, but still you can start bootstrapping with it. So this is used for porting this code base to some new platforms. It's rather difficult process actually. It's very difficult, but it can be done. So everything about it is in bootstrapping directory. Then this distrib directory is about building distributions. So how to build something which will be distributed then somehow with libraries required, with something else. There is a documentation, there is driver. Driver is about managing a compiler process. So when you want to compile something, some project, then you need to work with several modules, at least with other libraries. You should also, sometimes you should use some other compilers like C preprocessor and something like that. So this driver is about running all this stuff so on your project. GHC is about building final executable for GHC compiler. It's not a very big directory, just very small actually. You can look at it. There's nothing interesting there. So you can see this includes directory, and what does it mean for us? Includes. Who knows what does it mean? This directory in any code base. Yeah, it's exactly directory for C headers. Yeah. So these headers, they have lots of them. This is because runtime system is implemented mostly in C language. So that's why you will need many headers, C headers there. So we should have them in this directory too. Yes.
What's the percentage breakdown in terms of C versus Haskell?
You mean how much code is implemented in C? And I don't remember actual numbers right now, But I know that every year the percent of C code is becoming less and less. So if you look at the paper which I cited before, the Glasgow Haskell Compiler, but by Simon and Simon, they have, in that paper, they have a table with comparison. They have percents of C code for every component. And so right now we have only C code only in runtime system, but originally we had more of them. Yeah, what?
To answer the question, it's 82% of Haskell and 10% C.
But that's in this paper.
No, it's from the current GHC Github mirror.
Okay, so again, how much?
It's 82% Haskell and 10% C.
10.
And the remainder make by.
Yeah. Okay. So 10%. Yeah. So yeah, it's well, we need that for runtime system. Yeah, because the goal for the runtime system is to make it quick. So that's the main goal. So that's why maybe C is the best choice there. So in the very beginning, the most of this runtime system, and it was written by Simon Marlowe. So he was very good in writing in very performant C. All right, in place directory is where your results of building will reside. Every library, every executable will go to this in place directory while building. So after building, you can find there all executables just to check whether it was all right. iSurf is a directory for GHC interpreter, which works like a network service. So you can run GHC as a server, and then using network, you can work with it. You can provide expressions and get results from it. These two directories is about foreign function interface. It's about interfacing with other platform libraries, which are mainly implemented in C. NoFib is a benchmarking suite here. It's used for profiling. Test suite is tests, and utils is several files for different utilities which should be used during compilation, during compiling Haskell. All right, these are all of the directories are right here in the root of Haskell GHC code base, and now we'll follow two other components here. We'll first talk about libraries. So when you write a compiler, it's quite an interesting thing. So regular programmer never think about it, but when you have a compiler, you are very limited in tools that should be used. For example, if you want to implement something in Haskell, well, you need base library, for example. But in the very beginning, you have no libraries, because to get a library, you need to compile it. And in the very beginning, there are no compiler at all. So you cannot use something which is not available yet. So you have to think about it when you implement a compiler. So the first library, which is built in the very beginning, is this GHC prim library. It's several primitives like int, data type, or double, something like that. Very, very primitive things are in this library. So you need very small compiler in order to compile this library. So it is done in the very beginning of building. Then the next step, based on this one, there are two other libraries about integer. It's big integer implementation. There are two possible implementations. GMP, which is very effective. It's actually a bridge to the platform library, GMP. And you can use this library, and you can use another library, integer simple, which is very simple implementation without any dependencies at all. And at this stage, you can choose which library you want to use. So if you have a platform with GMP available, then you can use integer GMP. It will be more performant, more efficient. If you don't have such library, then you choose integer simple. So choose, when I say choose, means, well, you run configure script, and it tries to find out what you need to build, what you have on your platform, and then this script will choose what you need for that. So this is the second step. So you will need GHC Prim in order to build these libraries, but you don't need anything else. And then you have to compile base library. It's the third step. So you will need nothing more. So for that, so you will need integers and GHC Prim, and then you are able to build base. And when you have base, you have several other libraries to build. These libraries are quite special. Every version of a compiler is built against one version of base. It is impossible to have different base for one compiler. For example, GHC 8.4 can be built against base 4.11. And you cannot change that, because these libraries, they are very strongly coupled with a compiler. But when you have a base, you will need more libraries. This is a list of libraries, all of the libraries which are built together with a compiler. So all these libraries reside in this code base, so it's part of a compiler, actually. And you can think about these libraries as the most important Haskell library. So if you want to learn some Haskell library, this is the first list of libraries for you to use. So you should start studying with them. So these are the most important libraries that you will need for programming with Haskell. But these libraries, they don't depend on each other. In fact, they can be built in different orders. It doesn't matter. So just the whole last step of building. All right. So this is all about libraries. Then several words about runtime system. Runtime system is responsible for memory management. I will not talk much about runtime system in this workshop, because it's not our primary goal, but still you have to know something about it. So every garbage collection is implemented in C, in runtime system. They have also software transactional memory primitives implemented there. Everything about threads management is done also in runtime system. So if you know, GHC uses lightweight threads there, so you can run a program with thousands of threads, and these threads are somehow correspond to operating system threads. And in operating system, you normally don't have such thousands of threads available. Then runtime system implements several primitive operations, like basic input-output is implemented there, and some other primitive things. Then there is also bytecode interpreter. You can compile Haskell into bytecode, and then runtime system can interpret it. You normally use this bytecode interpreter for platforms which are not rich enough. So if you have a new platform, you don't want to write, and you are limited in the tools that are supported in this platform. In this case, you want to have this interpreter. So you compile Haskell code into bytecode and then interpret it, so the only thing that you need to implement this interpreter, and that's it. No need to do something difficult. And then dynamic linker, which is used in GHCI, is also implemented as part of runtime system. So that's it. Well, as we already know, 10% in C. So there is something in Haskell in runtime system, but most of these components, they're implemented in C. So mainly C there. Why do we need that? Why do we want to build a compiler? The first reason is to get something like that. So no Haskell user is able to work with odd version numbers like here. So it's impossible to get a release of Haskell GHC 8.5 or 8.1 or 8.3. It's impossible because every release GHC has even number. 8.0, 8.2, 8.4, 8.6 the next release, and that's it. And it's a long time of a tradition. So if you can build it on your system, then you can get these odd numbers. And here you can see it's a date of building. Actually, I faked it. I did not build GHC today, but it's better to show that it's very actual right now. So in order to get this, you just follow to this page, and there are first steps there. So several things. You run this command, run that command, run that command, and then you get whole brand new GHC on your system. In fact, it's not that easy. So it depends on your system how easy is it. So if you just update your system yesterday and then you try to compile, then it is possible to get some compilation errors. So, and if you get some of those, then you're unlucky, and it's quite difficult to find help about it. So when you build a compiler, because not too many persons build it in your system with your dependencies, and that's why it's a problem. Yeah.
Is there a Nix config file?
I'm not sure about Nix config. I don't think so. So I think that there was some progress in this, but I'm not sure about building in Nix. Maybe not. So I don't remember that already implemented.
If not Nix, is there some kind of recommended maybe?
It's not just about dependencies. It's sometimes they have problems with in new versions. They have problems with an order in which these dependencies are built. Well, normally, if you have a problem, it's a good idea to do make clean, and then to run make in just one thread, and there are several advice on that. So sometimes it's non-deterministic, you know. So there are many issues. Well, it's an old code base, and that's a reason. All right. So in order to do that, to build it, you have to prepare your workstation with many tools. So here you can see the beginning of the list of what you need. Yes.
From my experience, I think start with Linux. This is when you try it, don't try to build on Windows first.
Right. So yeah. So if only very very experienced GHC developers are able to build GHC on Windows. So
Not just Linux, but Debian Linux.
Yeah, this is usually what.
Goddamn. Okay then.
Yeah, right. And please don't use Arch Linux for that. Because they some time ago, about a year ago, they switched to dynamic building by default, and it breaks everything for Haskell developers.
Oh yeah.
So I'm one of a person who is I struggled a lot with that, but it's quite difficult. So yeah, just Debian is good for that. Yeah. So this preparation step, then you just get sources from GitHub. That's the easiest thing. Then you run this configure thing, which is very very old thing. And then you run make. So this make, it can be made in several threads, or in the very beginning it's better to do it in one thread without specifying number of threads. And this process of building is actually very long. So if you have a GHC compiler, an old version installed in your system, then configure will find that, and then it will try to use this version to build so-called stage 1 GHC compiler. Stage 1 GHC compiler is a simple Haskell compiler. It supports minimum of the features. So there are no too many extensions that are supported by this stage 1 compiler. So it's very limited compiler. It can be built using what you have in your system, with the compiler which is in your system right now. So if you don't have GHC compiler installed, then configure will try to arrange building stage 0 Haskell compiler, which is even more limited. And then it will try to use it to build stage 1 Haskell compiler. Then when you have stage 1 Haskell compiler, it will run building stage 2 Haskell compiler. Stage 2 is full compiler, which supports all features that this version of a compiler should have. So it normally build stops at this stage. And then you have in place directory, you have this stage 2 compiler. Its name is GHC stage 2. It's a name of executable. And then you can run it, check it, and everything else. Of course, you will have GHC available, because GHC is actually just one flag to GHC stage 2, like interactive. If you provide this flag, then you will have GHC. Then sometimes you will need to build stage 3 compiler. Stage 3 is normally used for testing. So if you have stage 2 compiler, then you can try to run it to check if everything works okay. So you just try to compile the whole compiler with it, and then you get stage 3 compiler. Sometimes it is used for checking optimization things and something like that. But normally you stop at stage 2. And then you have a GHC compiler in your system. In general, it takes more than an hour. Well, of course, depending on your system, but 2 hours or 2 hours and a half for the most of laptops. That's quite usual time for that. There is one rule when you try to read GHC directory. So here is it. There are many file types there. But there is simple rule. So if you don't know this file by extension, so you know, if you have HS or LHS file, it's about Haskell. If you have C or H file, then it's about C. But if you see something which you don't know about, it's build system. So it is very old build system, and it goes back to dozens of years. Well, maybe it's the beginning of 80s or even 60s sometimes. So there are many tools. Yeah, you can see this AutoConf, AutoMake, and many other things. So there are not too many specialists in there nowadays, unfortunately. But GHC still depends on this stuff. There is work in progress on removing it and building a new build system for Haskell, but still all this machinery is still there, and you cannot build GHC without it. And talking about this alternative new build system, I'd like to mention Hadrian. Hadrian is, well, he was originally Rome emperor, and one of the main maintainers or developers of this build system, Andrei Mohov from Newcastle University. Here just several links about him. His this Hadrian resides. It's actually development branches there, but you can find, if you remember, those Hadrian directory in the root of GHC directories. Everything is right there. So there is video about this build system. It is implemented in Haskell. It uses Shake build system by Neil Mitchell. Very good one. But still, when I consulted, I was pretty sure that when you have Hadrian, then you don't need all this AutoMake, AutoConf stuff. But unfortunately, you still need that. And Andrei told me that, well, unfortunately, there are too many proponents for that old stuff for building GHC. So right now, and there are too small amount of people who actually understand why do we need them, and they don't allow to remove all this old stuff from it. But they're working in this direction to make it everything by Haskell, to build Haskell using Haskell itself. So, but now it's not possible. All right, several words about newcomers info. What you can find there. So I mentioned already these first steps. So they're very simple. There is advice on how to rebuild code that you modified quickly. So this is very important, and I'd like to mention it and like to talk about it a little bit. One of my students several months ago said, I told that he's working with GHC code base, and I told him, well, why not try something like that? Just put some prints in different parts of the code just to see what is going on. And then you can change it. And he told me, oh, well, but it takes too much time to rebuild everything. So if you put one print instruction and then you compile it and it takes 3 hours, and then you see that you put it in the wrong place or something like that, then it's a problem. So actually you don't have to wait for all the time. When you develop something simple within this code base, when you want just to put one print instruction, there is no need to build Haskell compiler from scratch. So remember those stages, stage 1 and stage 2. It takes too much time to build stage 1, but you don't need to rebuild it every time. So in the build system, you have a special it's build mk file where you just specify that you don't want to build stage 1. It's just one argument in that file. You just say, well, please build stage 2 for me. And then if you change one file, then of course you will have to rebuild this file. Sometimes you will have to rebuild several other files, which depends on that one. But it takes not too much time. So just several minutes and you are done with modified GHC. So please remember this. If you try, you don't have to wait. So just you have to wait for the first time when you build it, and then just modify this argument in the build mk file, and every other change will go very quickly. So this is an example of this advice for newcomers. So generally you have to read them because it will help a lot. There is also some information on how to find something to work on. In GHC, they support this idea of low-hanging fruits. So this is a list of issues which should be doable quite easily. So you can go through them, find something for you, and then try to implement it. It's a good exercise. Some of them are really easy. And they're not about just fixing typos or adding something to the documentation. They're about implementing something or fixing some bug, but according to those persons who added them to this list, it should be easy. Sometimes it's not. So sometimes we have very difficult problems in these low-hanging fruits. Because, well, if for one person it's something easy, then it can take you forever to understand what is going on. But still, it's a good list, so and a good place to start. And there are other links there, where to look, what to read, everything like that in Newcomers Info. And there is one very important piece of advice in that Newcomers Info. Please read it. And I believe in this phrase. That's really true. So don't get scared. So it's really big code base, but you have to look at it. You have to try to understand it. From my own experience, one of the biggest difficulties when you try to stare at this code base is to decrypt their names. So they have normally they have prefixes for the names of the functions, names of the modulus, and if you get those prefixes, then many things becomes easier for you. So, for example, if you see something like TC somewhere, anywhere, for the name of the variable, name of the function, TC means type checker. So if you know that, you can understand quickly what is going on. Or like RN is renamer. And there are many such things in this code base. So before trying to understand everything, try to understand names. And if you know those names, then you're on the safe side. You will understand where to look. Okay, so it was very, very good advice, so please follow it. And now, well, there was a suggestion about structure of these workshops. So I've read those suggestions. It is possible to have a short break at this step, if you like. So, or we can continue further. So do you have any ideas? Maybe.
Like 5 minutes?
They're like 5 minutes, yeah. So if you have GHC, then you can look at it, or you can try to look at the source code which I provided in my GitHub repo. Feel free to ask questions. So okay, let's have this 5 minutes break. So now.